This is the headquarters of the National Oceanic and Atmospheric Administration, home to the U.S. government's National Weather Service. Their daily forecasts, watches, and warnings are essential information for everyday life on our planet. But there's a lesser-known group of forecasters working here in a special division called the Space Environment Center.
Our primary job is to monitor the sun and to put out the alerts and watches and warnings for solar activity.
Good morning, welcome to our 8:10 briefing. We had one long-duration C flare from the east limb. That's possible CME. We have not had protons, but we have had electrons.
One thing to note is that this region produced all the activity in December, so things might be picking up here in the next couple of weeks.
These space forecasters are on high alert for solar storms that might disrupt life on Earth. Solar storm clouds are made up of charged particles, so they're initially diverted around the planet by our magnetic field, just like waves breaking around the bow of a boat.
That turns out to be very important, because if it impacted the outer atmosphere directly, it would knock little bits of the atmosphere off into space. One reason why Mars doesn't have an atmosphere is that it doesn't have a strong internal magnetic field. And so gradually, over millions or maybe billions of years, the atmosphere was gradually knocked off into space by the influence of the solar wind and by CMEs that came past the planet.
But our magnetic field is not the perfect force field of sci-fi movies. Some particles can penetrate it, charging up the upper atmosphere. Solar storms will even bend and break the magnetic field lines on the far side of the Earth, allowing charged particles to zip back down the field lines toward the North and South poles. Extremely powerful storms distort the magnetic field even further, inducing electric currents that span the continents. When this happens, technology like long-distance power lines can become overloaded.
It can cause damage to transformers at either end of the line. In fact, in 1989, most of the Canadian province of Quebec blacked out because a transformer was blown out by a solar event.
If we have that storm that hits our communication system, it hits our power companies and all these things that we depend on, there's all kinds of chaos that can lay out there.
If power operators have time to react, they can reduce the current being sent over their wires and avert disaster. Satellite operators can also prepare for the onslaught with proper warning.
When there's a big space storm coming, they'll actually put some of their satellites to sleep so that the storm doesn't cause an electrical short or otherwise somehow knock out the satellite. So the more warning time they have, the better.
We wouldn't go sailing unless we knew what the weather was going to be. Similarly, when we have a large system like a power system or a telephone grid that can be affected by the weather in space, we need to know what the weather is going to be so that we can try and mitigate it.
Solar storms can also disrupt high-frequency radio communications used by aircraft. In the 1980s, Air Force One was transporting President Reagan on a trip to China when a solar storm struck. All communications were lost for several hours, effectively severing the head of the United States government.
The urgency is just like our Earth's weather. When we have a tornado warning, we know the urgency to get that out to the public, to let people know that this is happening. The same thing is with space weather. Users of this information need to know it, and they need to know it now. Just a few hours back, we experienced a coronal mass ejection. We want to see where this blast is going out, and then we can measure that and see how long it might take from that to reach the Earth from the sun. We're seeing a very huge explosion of material that's coming out, and if you look at this small image here, here's the sun that's covered up, and look at the mass that's being thrown out into space. So it's huge, very huge.
Because magnetic field lines emanate from the North and South poles, energy from solar storms has easy access to those regions. For that reason, experts worry that airplane passengers flying over the poles during a powerful storm might be exposed to harmful levels of radiation, perhaps a dose equal to 100 chest X-rays.
It's not something that we want to mess around with, because we never know when that radiation might all of a sudden become a lot more intense while there's an airplane in the sky.
The threat from solar radiation is just one more reason scientists keep a close watch on our sun.
It matters, especially in modern times, what the sun is doing. Earth is not an island. We are a participant in the activities of the solar system.
Sunspots are the triggers for most severe solar storms, so forecasters track them carefully as they rotate across the surface of the sun.
Location, location, location. We see coronal mass ejections all the time from the sun. A lot of them are as the sun is rotated around or from the backside of the sun. That would not be faced toward the Earth, so that would be less of a concern. As the sun rotates around and that active region gets more into the center of the disk looking at us, then that's when we would be concerned with. From the center of the sun, as it rotates around, is the kill zone.
As the sunspot rotates around and begins to face directly at Earth, that's when we really have to worry about a storm. If a big storm lifts off then, it can aim directly at Earth and the full force of the storm slams into the planet.
It's like a shotgun aiming at a target. The more dead on the shot, the more likely serious damage will be inflicted. With great danger also comes astonishing beauty. Solar storms generate majestic planetary light shows. The shimmering curtains of color, called the aurora,